Hi, in this video I am going to show you how to perform k-means clustering in R. K-means clustering is an unsupervised learning algorithm. So we use unsupervised learning algorithms in data which has no target variable, or which is an unlabeled data. So data where the target variable is absent, we do not know the different categories or do not know the different levels for each rows of the data. Okay. So we'll take a data set to demonstrate how we can use k-means clustering. We'll take the iris data. You might have seen this data being used in my other videos. I'm going to show you how this data looks like. It's there in the library datasets. You can get it from there. So this is how the data looks like. Alright, so we have got the different attributes of the flowers. We have got three species of flowers, Setosa. Okay, let me show the complete data. That is better. Okay, so we have got three types of data: Setosa, versicolor, and virginica. Okay, so the last variable species has the levels of his data. Okay, the levels, that means what type of flowers we have, and we have got the different attributes of the flowers: length, sepal width, petal length, and petal width. Okay, now this is a level data. Okay, we know for sure that which observation belongs to which species. First observation is Setosa. If you go down, you will find other observations with versicolor and so on. But we'll use this only the first four attributes, and without using the last variable, which is species. We will try to categorize how many categories or how many segments of the data present in this particular data set. Okay, and that's the reason why we build clustering models, right? We try to find clusters, how many clusters or how many segments that is present in the data. Okay, and then we will try to compare with species. Okay, because we already have some specified spec segments, but we won't do that for analysis, but we can use that for comparison purpose, just to see whether the clustering algorithm works the best or not. In more real world problems, you won't have this the target variable. So here we have the target variable and we are taking it out just to make it an unlabeled data. But in real world problems, you will not have this target variable. So comparing the result will be slightly more difficult. Okay, so let's first see how this data looks like. So we'll try to plot it. We'll try to plot the attributes, both petal length and petal width, sepal length and sepal width. We'll try to plot it first. Okay, so we'll use ggplot and get ggplot library first onto your R session, and then we'll use the iris data. We'll use the petal length and petal width, and the color that we are specifying is species. Now that's only for sort of analysis purpose, but when you actually run the clustering algorithm, we will not take this particular variable. Okay, it's just for visualization purpose. I'm going to use this one, and let me show you how it looks. Now you can see the three section of this data point. One is red, the other one is sort of green, and the third one is blue. And you can see the three different species, Setosa, versicolor, and virginica, are being clearly segmented or clearly clustered using these two variables, petal width and petal length. So petal length is there in x-axis and petal width is there in the y-axis. So use this combination of these two attributes, we are able to segregate the three species into three different categories. You can see they're completely different, right? There is a clear segment. You can draw a line over here, and that's one segment, and you can draw a line over here, and then that's another segment. So the three segments are clearly identifiable. But if you take sepal length and do this, sepal length and sepal width, the attributes of sepal, it's not that clear. Let me show you. Yes, so the first species is clearly identifiable, clearly different from the other two, but versicolor and virginica, they are very overlapping. There seems to be hardly any segmentation, right? So the one that is in red is clearly identifiable or different from the other two species, but that's not very clear. But using the four attributes, that would make more sense, or rather that would make the identification or clustering much more clearer. Okay, and let's see how that is possible. Okay, clustering is an unsupervised learning algorithm, so we are not going to use the target variable. So we will assume as if there is no presence of target variable. Okay, so far we have just used the target variable for visualization purpose, for our understanding if at all this data is good enough for clustering, if there at all there seems to be some clusters or segments present in the data. But we'll see that only by running the algorithm, because visualization is not just enough. If we are trying to reproduce the result, always make sure that you take a seed so that the same results can be reproduced. Okay, so so the syntax is very simple. We are going to call the k-means function, and we'll provide the attributes. Okay, so we're going to provide the four attributes: petal length, petal width, sepal length, and sepal width. Okay, there are four attributes, and we're not going to tell the algorithm that there is a variable species in our dataset. That's not given to the algorithm. So using these four attributes, the algorithm is going to find out how many clusters are there, and if at all they are different from each other, and which observation belongs to which cluster. So these are three things to be expected from the algorithm. Now we know that there are three clusters, right? So we can mention, well, that's optional, but we can mention that there seems to be three clusters in our dataset. So we can provide the value 3, okay, which is nothing but k, right? So in k means we need to provide the value of k. That means how many clusters we want from this data, or we expect from this data. And we know that there are three clusters. We just need to find out which observation belongs to which cluster. Now that's somewhat now easier for this algorithm to identify, because we know for sure that there are three clusters in the data. So we are going to use the four attributes, and they are in the, if you look back the data set from column 1st to column 4, we have four attributes, right? So we'll just use iris, and then within close bracket 1 to 4. We'll use the four attributes without using the last one, which is spaces. And 3 is like, because we are sure that they're going to be three clusters. Okay, let's run this. Now the k-means clustering algorithm has run. Now what happens in k-means is that it randomly assigns three centroids in the dataset. Okay, it starts with that, and then it calculates the distance from each data point from the centroid, and then it iterates. That means it then is assign a better assignment of centroid, and it keeps on doing it till the time the algorithm converges. That means the centroid identification within the data set is the best, or is the optimum. So that's the way the k-means algorithm works. Now if you're not familiar with clustering algorithms and how k-means clustering is different from other forms of clustering algorithms, like hierarchical clustering algorithm, there is a video on this description section. You can watch that video. There's a clear description of what k-means algorithm is and what the other clustering algorithms are, and you can get a better idea. Alright, now that we have run this algorithm, let's see the result. Okay, now we have saved this in this particular variable iris cluster, and let's see how the result looks like. So here is the result in front of us. So as we have given that k-means clustering with three clusters with size 62, 50 and 38. That means the first cluster is having 62 observations, the second one is 50, and the third one is having 38. Okay, now let me tell you that each species we used to have 50 observation each. okay, in each species. That means there are 12 observations that has been misclassified, or that has gone into a wrong cluster, right? Because ideally we should expect 50 50 50, right, in the result, but we have got 62 50 50. That means the middle one, the second cluster, is fine, but the first cluster is more by 12 units and the third cluster is less by 12 units. Okay, and the way the cutoff value has been used for each of these attributes has been given below. So for the first cluster, anything with the cutoff value, this four cutoff values for each attributes has been assigned as cluster 1. Okay, similarly the next cluster, and then similarly the last one. Okay, so these are the cutoff value that have been used to identify the clusters for each observations. Now we have got 150 observations. Now for all 150 observations, we have now the identification. The first observation belongs to the cluster 2, second belongs to cluster 2, and so on. So you can see how the cluster observations assignment has been made by the algorithm. Okay, so that's there. All right, so that's the way. Now you might be wondering that we don't have a validation statistic, right? Like supervised learning, like linear regression or logistic regression, we used to have some sort of a validation statistics where we get to know how efficiently the model in identifying the target variable. But here we don't have a target variable, so validation is a much difficult task here. Okay, so we know for sure that there is some misclassification happening, and we will get to know that only by doing the validation with the actual classified data. Okay, fortunately we have that here. We know for sure that which observation belongs to which species, but in real world it's not that easy, right? Because you won't have that classification. So here we can easily get it, right? We can easily validate. So how we can easily validate is that, so we have the classification using k-means, and we already have the actual classification which is already there in the data, right? The variable species itself is a classification. So we are first taking so we are tabulating it, right? So the first one is the the predicted value of cluster, and the second one is the actual cluster. Okay, and let's tabulate and let's see what is the accuracy level. And here is the result. You can see okay, you can see that there is misclassification. Okay, here, right? So 50 Cetacea has been classified correctly. There is no issue with that. 48 versicolor have been classified correctly. Okay, there is only 2 misclassification happening. For Virginica, only 36 have been identified or classified correctly, but 14 have been misclassified. So total number of misclassification that's happening is 14 plus 2, which is 16. Okay, so that's the misclassification, and you can actually calculate the misclassification error, right? Out of 150, 16 has been misclassified. So 16 by 150 is the misclassification error. Okay, and we can in fact calculate, right? 16 divided by 150 is your 10%. So 10% misclassification error is happening. Now, how do we know that this works the best? Well, the way we can try out, let's say maybe to decrease the misclassification error, is by involving more number of variables or creating more number of variables. We don't have more number of variables here, but by increasing more number of variables, this error rate will go down. So that's one way of decreasing the error rate. The other ones could be identifying the outliers. K-means clustering is very sensitive to outliers. So if you can identify some of the outliers, remove them, this misclassification error rate will go down significantly, right? But remember one thing, this way of validating is not possible in many situations where we do not have a target data as such. So in those situations, what we will do is that we will use multiple clustering algorithms, not just k-means. We'll also use hierarchical clustering algorithms, agglomerative clustering algorithms and so on, and we'll compare the results, and we will see where exactly we are getting a better segmentation, and that we'll get to know by expert judgments, one way. Second way could be, if you have some level data, we can just use that level data to see if that works better or not. I mean, which one works better. Okay, so that's the way we use k-means clustering to perform clustering. Thank you.